Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 math handout, problem number 1. I will be taking my known values from the Chapter 7 math handout shown here. So here's problem number 1, and it shows me my total voltage of 18 volts and the value of my 3 resistors, which I have already filled in here. I also will be applying from the series parallel rules sheet. Here's our rules for series. Chapter 6, parallel Chapter 7, and I've taken and clipped out the rules for parallel that you see on the screen here. I also have Ohm's law down below and the power formula that we will be using as well. So as I said, I begin by filling in my known values. I have 18 volts VT. Sometimes you will see VA, which means applied voltage. VA and VT are used interchangeably. I have an R1 of 30 ohms, an R2 of 20 ohms, and an R3 of 60 ohms. If I look at my rule for voltage in a parallel circuit, it shows me here that voltage stays the same in a parallel circuit. So I can go ahead and fill in all of my voltage values, 18 volts all the way down. The next thing I'm going to do is I'm going to calculate my RT value. Now if we look here, we see that we cannot simply add up the resistance, but we must use the reciprocal formula. Here it says REQ, which means equivalent resistance. Here I have RT. RT and REQ are used interchangeably. So watch the calculator closely. I'm going to find the total resistance for a parallel circuit using the reciprocal formula. So I'm going to hit 1, hit over under, hit 1, hit over under again. I'm going to punch in 30 ohms. Scroll over, hit plus, hit 1, hit over under, 20, scroll over, hit plus, 1, over under, 60. Feel free to rewatch that as much as you need to see exactly how I done that. Hit equals, and that tells me that my RT is 10 ohms. Please keep in mind that your total resistance will always be lower than your lowest resistor. So if I was to put a 5 ohm resistor in here instead of, let's say, the 20 ohms, I'll keep the 60 ohms, but if I put a 5 ohm in here, the total resistance will be lower than 5 ohms. The total resistance will always be lower than the lowest resistance. Alright, now that I have my RT, I can find my IT using Ohm's law. If we look right here, if I'm looking for I cover up I, and that shows me V divided by R. So I take the 18 volts divided by 10 ohms. Hit equals, hit engineering, 1.8 times 10 to the 0, so that's 1.8 amps. Next, I'll find the value of I1. I have the 18 volts, I'll leave that in there. I'll change the bottom number to 30 ohms. Hit equals, hit engineering. This tells me that I1 is 600 milliamps. V2, leave the 18 volts in there, change the bottom number to 20 for the 20 ohms of R2. I hit equals, hit engineering. I have 900 milliamps for I2. For I3, I'm going to change the R3 to 60 ohms, and that gives me my I3 value of 300 milliamps. 300 milliamps, 900 milliamps, and 600 milliamps will add up to 1.8 amps. All right, last is my power. So I have total power would be equal to IT times VT. My power formula right here, if I'm looking for power, I cover up the P, and it's equal to V times I. So I'm going to put my 18 volts in first, times the I of 1.8 amps to get my total power of 32.4 watts. Next, for P1, I'll do I1 times V1. So my V1 is 18 volts times my I1 of 600 times 10 to the negative third, 10.8 watts. For P2, I2 times V2, so I have an I2 of 900 milliamps. That gives me 16.2 watts. And finally for P3, I'll do 300 milliamps times 18 volts. So I'll go up here and I change the 900 to 300, and that gives me 5.4 watts. So now that I've done all my calculations, I can fill in the blank here for IT, RT, and P3, and these will be the three answers that I'm looking for on the Chapter 7 Math Handout Canvas Answer Sheet assignment on your Canvas page. Thank you.